For the extra credit assignment involving R, the first step is probably to download R. I'm assuming most people don't have it at this point, but getting R is not a big deal. It's not very big. It doesn't take very long. Go to rproject.org. You can either type in the URL directly, or if you do a Google search for R project or R statistical software, you'll get it. Then download R, click on that hyperlink. Then there will be a big list of mirrors. Pick one that's sort of close to where you are geographically. Then under download and install R, there are three options: Linux, Mac, and Windows, and then just pick the appropriate download that goes along with your operating system. And like it says at the bottom, make sure you avoid the tarball. That's the common mistake here. That's why I put that in there. You'll see what I mean when we run through this. There's rproject.org, and in the red oval is the link that you want, download R. There's the list of mirrors. It's scrolled way down to have the US ones on there. Wherever you are right now, pick one that's kind of close to you. That tends to work a little bit faster. I guess you can tell from the ones that are purple which ones I've used. The one that's closest to us, I guess, would either be that Tennessee one or Dayton if you're in Lexington. I used the Tennessee one and the Iowa one because I tend to go right for the HTTPS links. So that's why I end up with those. But anyway, the next thing for any of those, the next screen will look like this. So in that first box where it says download and install R, there are three options. Pick the one that matches up with your operating system. The other thing that's circled that ends with .tar.gz, that's the tarball. You don't want that. It's the source code. If you download that, it will work, but you have to compile it yourself. That would be impressive, but that's extra work, so I don't think I would go that route. Doing this for real. So I'll do it using a Google search to start off with. We'll say R statistical software. I don't even have to type the whole thing out. There it is. Then download R. Then the mirrors, I'll pick Iowa State. There's Iowa State. And I'm running Windows, so I would click this link. If you have a Mac, it's that one. And I guess if you have Linux, it's that one. From this point forward, the installation is pretty easy, and the rest of this video will be, once you have R downloaded, how to get it to do what you need it to do. We're going to go through the Bootstrap confidence intervals document first, because importing data from a CSV is slightly more advanced. I think chronologically that should go last. But if we're going to construct a Bootstrap confidence interval, we have to have the data stored in R first. So the manual data entry and storage is what we're going to begin with. The function that you need is C for combine. Basically what that function does is it takes a bunch of individual numbers and combines them as one set, which is ideal because then we can have our sample as one big chunk so we can recall the entire thing with a single term. So there's the C function combining those numbers together. The arrow is effectively storage. So I'm storing that combined list of numbers as original. That way, after it's stored, when I type original, R will know what that means. So to type this into R in the console, I guess you can tell that I have an older version of R here. So you're going to have a more updated version than I have, but that's okay. All the commands are going to be the same. I don't like having this blue stuff up here. It doesn't really matter, but I'm going to dump it. If you go to File and then, or Edit, and then Clear Console, it's gone. That's just a personal preference thing. You can leave all that blue stuff there if you want. What some people like to do is, instead of typing directly into the console, to have a script and then copy it over. If you go to File and then New Script, you'll get this window, which is like a text file, basically. It's like using Notepad. And you can type your procedure in there and then just copy it over. I would do that if I was going to write a lengthy procedure, but I'm not. I'm only going to write a few lines of code. So even though this would be viewed as an amateurish maneuver by a programmer, I'm going to type directly into the console. So the first thing was to store the data. I should point out you can call it whatever you want. I'm going to retype this as original just like it is in the PowerPoint. It's just a term, it's just a placeholder, it's just a name, so R knows what you're talking about. But just to keep everything consistent, I'll call it original. So C, then 18, 14, 9, not 8, 26, 49, and 35. One thing I did do differently here, and this was on purpose, was I left the spaces out. So instead of 18, comma, space 14, comma, space 9, like that, I don't have the spaces there. That doesn't matter. because if I retype original just to print this, it's the same. All those numbers are in there. Spaces or no spaces, that doesn't matter. Everything is going to be case sensitive though. That'll matter a little bit later. Okay, so now we have the data stored in R, but if we're going to create bootstrap samples to compute bootstrap statistics and eventually get a bootstrap distribution, we have to be able to store them too. So we have to have a place to put them. And usually the default is to have 10,000 bootstrap samples, not 5. And we had 5,000 using StatKey just because StatKey struggles a little bit after you get up above 5,000 or so. But the general standard is 10,000. It won't take R any longer. It'll be a split second to do the 10,000, so we might as well do it. So you need to get a place to store 10,000 values. So what I'm doing in this second line of code here is I'm creating a vector. It's just essentially a list with 10,000 entries where we can store 10,000 numerical values, just so this way we have a place to put the bootstrap sample means. I'm calling it bootstrap means because that's what's eventually going to go in there. You can call that whatever you want. If you want to call it Fred, that's fine. And just remember that when you reference it later, that you would call it Fred then too. You can call it whatever you want. If you want to shorten this up and just have it as BSM for bootstrap sample means, that's going to work. Just call it BSM later when you need it in another function, whatever. The numeric function is just to say that we need this vector with 10,000 entries and the things that are going in there are numbers. Okay, so bootstrap means was what I called it in the PowerPoint. And then a numeric vector of length 10,000. So now that's ready to be used. The next step is actually generating the bootstrap samples and computing bootstrap sample means. This is going to be the part that's the most work, especially if you're not used to programming at all. If you are, you're looking at this and going, oh yeah, this is a basic for loop, that's not a big deal. But this is heavily dependent on experience. If you've never done it before, this is going to be the part that's tough. The three pieces that have to be here, I have them in a bolded list there. The first thing is the actual loop, the for I in 1 to 10,000. That says that whatever the procedure is following that, to cycle through the first 10,000 positions of that vector and do that procedure for each position. In our case, since our vector is of length 10,000, the first 10,000 positions is all of them. The next part of that line of code where it says bootstrap means I, that's saying that in the ith position of the bootstrap means vector, where I is some number between 1 and 10,000, do what's on the other side of that arrow. And what's on the other side of that arrow, which would ultimately end up being stored in the vector, I have a nested function there. So working inside out, the inside function is sample, where I'm sampling from the thing that I called original, which was that set of 6 numbers, and the replace equals t means sample with replacement, because that's how bootstrap samples are taken. They're done with replacement, not without. So you want replace equals t, not replace equals f. So we're taking a sample from that original sample, and it'll be of the same size. That part is a default setting. You don't need to worry about that. And then after you have the sample, the other function is the mean, the outer function. Once you have that sample with replacement, take the mean of the numbers in that bootstrap sample and then store the mean in the vector. So there's a lot of stuff going on in that functions there, but if you recreate what I have there, it'll work correctly. Now to do that in R, so I need my for loop, so for I in 1 to 10,000, then bootstrap means I, so for the ith component in the bootstrap means vector, this is what we're going to store there. The mean of a sample from original and replace equals t. And that should be enough parentheses. Yep. Another thing that will happen, and I guess I can show you, there's a couple things I can show you right now actually. If you mess up a line of code, if you use the up arrow, you can cycle through the stuff you've already typed. So there's me pressing the up arrow, and then the down arrow will go back through it. But I just want to show you this. What if I missed the last parenthesis? So I had this where I'm missing a right parenthesis, and then enter. R gives you a plus. When that happens, your first thought should be, I'm missing a parenthesis, because now if I put in a right parenthesis and then enter, I'm getting a prompt again, so now it's fixed. In reality, you just need that for loop once, not twice, but I did just want to point that out. And at this point, you could print that entire vector if you wanted to. I wouldn't recommend that because it's huge. I can show you what happens. You get that, which is probably not what you want. You don't need to see all of the numbers. Ultimately, you just need to see the endpoints. So I'll just recreate what we had at the beginning. So original sample, then I needed vector, and then there. Now we're back to where we were without that printed vector. The last thing is to get the endpoints of the confidence interval. Okay, like it says up at the top of the screen there, you can get a histogram if you want it, and then in order to get the endpoints at the interval, the easiest way to do it is just to use the percentiles, which in R, they're called quantiles. Those are essentially the same thing. It's just quantiles are phrased as proportions and percentiles are phrased as percents. That's about the only difference. And these screenshots that are here, the two that are on the left are if you wanted to get them individually. There's no point in doing that. I think it's easier just to get them simultaneously. If you look at the screenshot that's in the lower right, instead of specifying one quantile, I'm specifying two using the combine function, where I'm saying, give me both of these. Give me the 0.025 and the 0.975 simultaneously, and then I just get my two endpoints with one function instead of two. That's what I would suggest doing. It's a little bit faster. If you want to get them individually, that's not wrong. It's just that that's 2 lines of code instead of 1 line of code. If I'm going to recreate that, so quantile from bootstrap means, and then I'll just do it with the combiner, 0.025, 0.975. There. And I happen to end up with the exact same endpoints of the interval that are there in PowerPoint and that are there on that instruction sheet. Oh, and for completeness' sake, you don't need it for anything, but if you really wanted the histogram, it's hist is the function. And then it pops up in a separate window. So if you wanted it, you can get it. And we're getting the nice shape, basically, that we want, right? It's not perfectly symmetric, but it's pretty close. The other thing that you'll have to do is construct a bootstrap confidence interval for a single proportion. The functions that we're using are a little more geared toward quantitative data. So for a sample proportion, you basically have to write it out as ones and zeros, and then the proportion would be an average of ones and zeros. That's the way that you get this to work correctly. Other than that, the rest of the steps are actually going to be identical. I called it p hat. So p underscore hat, since that's our notation that we use for a sample proportion. The way to get the ones and zeros really fast is to use the rep function. Where I have rep 124, I'm saying I want 24 ones, and then rep 056 is saying that I want 56 zeros. That's a lot easier than manually typing out 24 ones and then 56 zeros. And then I'm using the combiner to combine that all into one group, and that way we have our sample proportion in there. Okay, so let's get rid of this stuff. And then now we can do it. So p hat, again, you can call that whatever you want. I thought p hat was the most straightforward name that I could use. And then combine, and I'm going to replicate 1 24 times, and then I'm going to replicate 0 56 times. So there's the sample proportion in there. And then everything else basically works the same. If you look at what's here, you need a vector with 10,000 positions in it. I called it BOOTPROP for bootstrap proportion. Then it's the for loop, where for each position in that vector, we're going to take a sample with replacement from that original sample of ones and zeros. And then we're going to take its mean, which is effectively a way of getting a bootstrap sample proportion here. We're going to do that 10,000 times, and then The quantiles there are for a 99% confidence interval. So there it would be the half percentile and 99.5 percentile, so in decimal form, 0.005 and 0.995. Okay, so doing it in R, I'll use the same names. Again, the boot prop, you could call that whatever you want to call it. But whatever you want to call it, it's a numeric vector with length 10,000. And then for I in 1 to 10,000, boot prop I. And what's going to go in there? Same nested function. So we're going to sample from p underscore hat with a replacement. And then once we have that sample, we're going to take the mean of it. And we're going to do that 10,000 times. Then quantile from boot prop. And then I'm going to use the combine function again to get both endpoints at once. And then 2 right parentheses and there. Again, this happens to match up exactly with what's on the instruction sheet in the PowerPoint. The other instruction sheet is how to import data from a CSV file. We already have a way to get data into R, which is to use the manual entry. But maybe you don't want to use the manual entry. Maybe your data set's really big, or maybe you're just worried about mistyping stuff and you want to take that possibility away. And this is a way that you can do it if you have all the data stored already. There is another way to do this that would look more descriptive in an instruction sheet, which would be to use the actual file directory, but that varies from one operating system to another. With a Mac, you can drag and drop, but you can't with Windows, and there are things like that. So the simplest thing is just to use file.choose. Read.csv, that function, is telling R that I'm going to bring in a CSV file because R already knows what those are. R knows that that's something where all the different values are separated by commas. It knows how to read them. File.choose is a way that you can pick out your file. You just do it with the 2 parentheses like that with nothing in between them. That's the way that you're supposed to type it. You'll see it in a second when I run through it. And then header equals T because whatever we're going to have, there will be a header there. So that physics data set, you can see it on the instruction page. There's a printout of it in the upper right corner, but I've got it in here too. So that's the first thing that I'm going to do. Again, I'm going to clear my console. And then I want that physics graduate school data. I'm just going to call it physics, and then read.csv, file.choose, set of parentheses, and then header equals T, because if you look in the upper right corner, there is a header, stipend, acceptance rate. Those are in the header. They're not actual data. When I hit enter, it's going to open a window, and then I can just pick out whatever I want. And there's physics graduate school. Okay. Now it's in there. If I type physics, there it is. Just like at the bottom of the first page of that instruction sheet. The notes, which are basically things to watch out for, case sensitivity does matter. That's going to matter very shortly when we go to extract an individual variable out of a CSV file. Then the other thing is you don't want to have any formatting. So if you have big numbers, by which I mean numbers that are larger than 1,000, or I guess really larger than 999, you don't want to have any commas in there, because if this is a comma-separated file, then that comma would be viewed as a separator, and that's a problem. The other thing would be no other symbols, no dollar signs if it's currency, things like that. You want no formatting at all. Like it says there, once you've read in the CSV file, it's basically just a giant block. You've got to separate out the variable that you want or variables that you want, which are going to be in columns. Even if you have a file that just has a single column, you have to extract that one column, which sounds redundant, but it's true, although I guess that doesn't apply to this specific example. And this is why you don't want to have a dollar sign in your CSV file, because the dollar sign is a command in R. The dollar sign command is when you want to extract a specific column. It's however you stored the CSV file, then dollar sign, then the column that you want. So if you wanted stipend, notice how I've got it where it's physics, which is what I called the CSV file in R, then the $sign, and then stipend. The $sign is saying, I want a column, and then after the $sign is the column that you want. For me to go through this in R, I'm actually going to do it the wrong way first, where I'm going to do it as though I forgot about case sensitivity. So let's say that I want stipend, and so I want the thing that I called physics, $sign, and then notice I'm doing this wrong because after the $sign, that S should be capitalized because it's capitalized in the CSV file. R will accept that command because I didn't use any function improperly, but watch what happens now. If I type stipend just to print out what's there, there's nothing there because there's nothing in physics called stipend with a lowercase s. So there's nothing there. You want it with an uppercase s, so I'm going to do this the lazy way. Use the up arrow to get back to where I had that command, and then just fix that one letter. Now if I print it, there it is. So beware of case sensitivity. It's really easy to